Let's take a closer look at my TNT transmitter here. First of all, I have to tell you that when this transmitter is running, there's 300 to 400 volts right here on this coil here, and so the whole transmitter is, you have to know exactly what you're doing. There's lethal voltages all exposed on this transmitter. It's a 1929 design. At that time, amateurs were not real concerned about safety. They were doing things to make it run. And in fact, this transmitter here puts out 3 to 4 watts on 80 meters the way it's set up. It's designed so that by changing two coils, by changing this coil here in the plate circuit, changing this coil here in the grid circuit, it can run on either 40 or 20 meters. I've used it on 80 and 40. I've never trusted it to run on 20 meters. Basically, this transmitter is a push-pull, not oscillator, using a couple of triode tubes. These are these tubes right here. These are type 10 tubes. Fairly hefty tubes for 1930 when this design was published in QST. The way I have it set up here, the transmitter runs at about 10 watts input, puts out about 3 to 4 watts. What you see here is a tuned circuit consisting of this capacitor and this coil here, and that sets the operating frequency. It's link coupled using these two coils here combined with this capacitor to set antenna loading, and that is the how you maximize the output. Okay, there's a few things about the TNT transmitter. One thing is it tends to be microphonic. It has to be sitting on a table separate from the operating position. The other thing is it's very susceptible to hand capacity. Anytime you bring your hand close to this tuned circuit here that sets the frequency shifts. So in that case then, when you set the frequency, when your hand is part of the tuned circuit, you pull away, frequency shifts. So it's a bit of a trial sometime to get right on frequency, but with a little patience it works. It's a neat transmitter to use on the air. It works, and I've used it to make several contacts.